Hello, everyone, and welcome to the first episode of the Human Survival Archive. Today, I'm honored to be joined by Jonathan McDowell. Welcome to the Human Survival Archive, Dr. McDowell. It's a
Thank
pleasure to have you, and thank you so much for taking the time out today to join us. To begin, could you briefly introduce yourself and tell us about your background and the work you're doing?
Right, so I'm Jonathan McDowell. I'm a honorary professor at Durham University and a researcher with the Center for Space Environmentalism. And I recently retired from about 40 years at the Harvard-Smithsonian Center for Astrophysics. And so I've had a career as an astrophysicist, studying black holes and helping operate the Chandra Space Observatory. But I've also had a sideline, which is now my main line, in space environmentalism and space sustainability, as well as just nerdy collection of being I am like the curator of the list of all the rocket launches. And so I got into it, from this just interest of, wow, it's amazing we're going into space now. I want to know all about it. And there's no good list of everything that people are doing, so I'm going to make a list. And as I made the list, it became impossible to ignore the fact that, there's an awful lot of junk out there, and there are actually some issues that maybe we need to talk about. And so over the years, I've steadily sort of progressed more and more from just a train spotter to being an advocate for sustainability in outer space.
Okay, wow, that's wonderful. That gives us more into what you're into now and how you've pivoted from how you started off. Could we dive more deeper into what you're currently doing? Like, how is your work more important to humanity's survival?
Right. Well, I mean, there's the near term stuff, right? Which is that most people don't appreciate how much 21st century society is layered on spaceborne infrastructure. And I mean, now, kids your generation don't know how to read a map because GPS goes down, and that's one example. But even bank transactions go over satellite communications links. There's all kinds of that. We're living in a networked world, an instrumented world, where everything knows where it is. Right? It's a smart world, if you like a horrible description. And that smartness is connected by space sensors, both flowing information around the world, but also everything we know about climate change, not everything, most things we know about climate change are coming from space satellites, particularly NASA ones, but other countries too, that are taking the temperature of the Earth. In some cases, literally, but more metaphorically as well. And so space is just a crucial way. I think of the space system as both, our nervous system, but also our Fitbit that is our heart rate and for the whole Earth, right? And we want to make sure that that system it can be used sustainably and also isn't going to ruin the Earth's atmosphere. There are issues with that we can talk about. Then in the longer term, I see space as becoming only a more important field for human activity. I do believe there will be humans living off Earth in the
Yeah.
long term, that we will settle, if not Mars, the moons of Saturn or something like that, right? We'll fill the solar system. And, you know, every time humanity goes into a new domain, like the oceans, right? We go, oh, the oceans, they're enormous. We
Yeah.
can put all the junk we want in them. There'll never be a problem, right?
Uh-huh.
Oops, huge plastic Pacific floating garbage patch. I didn't think of
Yeah.
that. And so exponentials will bite you every time.
Mm-hmm.
And so things that seem like really big, a few generations, we humans are really good at figuring out how to use it up. And so we're just at the beginning of this space adventure. Maybe it'd be a good idea to be a little more thoughtful about how we use space than we were about how we use the oceans and the atmosphere and so on. And so that's really where I'm coming from, is that I would like to see this science fiction future, and I don't want it to be a dystopia. And so there are all kinds of ways in which we have to be thoughtful now to be able to use space sustainably.
People overlook this and they just think we just want to have people on Mars. We just want to have this done, but they don't realize all these other factors that you're talking about. We know that there's so many fields out there that have challenges. So what do you think is currently the biggest obstacle in your field right now?
Right. Well, I mean, as usual, the biggest obstacle really is lack of information on certain things. There's a couple reasons for that. There's two kinds of big information barriers we have. One is that there's been a switch in the past 10 years from space being mostly government to space being mostly commercial.
Right.
And in the West, somehow the commercial companies have managed to, I don't know, corrupt the regulatory agencies to the point that they can just say, oh, that information is proprietary. And the regulatory agency says, oh, we won't make that public then. Instead of going, no, this is public interest. You have to release this information, which is what they should be doing. But it becomes more and more hard to assess the environmental impact of these systems when the companies involved just won't give you the basic data about what they're planning to do. And so we need to stamp down on that. We need to require in the public interest more information released from these companies, all on an even basis so that no one has a competitive advantage as a result. And so that's something we need to do. But there's another problem, which is that we're worried right now because the new generation of satellites are mostly in low orbit, and they mostly are this sort of, instead of the old idea, which was let's eke every last minute we can out of the lifetime of these satellites, it's no, after 5 years we'll have a better version, so we're going to throw the old one away and replace it with a new one. And how do you dispose of your satellite? In low orbit, how you do it is you use the Earth's upper atmosphere as an incinerator. And so in a satellite, to be orbiting the Earth, you have to be going at 17,000 miles an hour.
Mm-hmm.
That's the physics of it. And so if you go at 17,000 miles an hour, 200 miles up, that's fine.
Mm-hmm.
If you lower your satellite down to 100 miles up, you're going through the outer atmosphere, and going at 17,000 miles an hour through the outer atmosphere, you burst into flame and disintegrate. And that's called re-entry. What they do is they lower the orbit, they incinerate their satellites in the upper atmosphere. Okay, no mess, no fuss, we're gone. That's one way to dispose of it. Except that, well, if you're not careful with the design of the satellite, chunks of the satellite can survive re-entry and potentially hit you on the head. But even if you successfully design your satellite to entirely melt, that material doesn't vanish, right? It's molecules. Those molecules enter the upper atmosphere. A lot of it is aluminium, or aluminum for Americans. And so you're adding these metals to the upper atmosphere, which is very thin. One thing to add a bunch of pollution to the lower atmosphere, which is dense, there's lots of air. The mesosphere, where these satellites break up about 40 miles up or something like that, is very thin. There's not a lot of it. And so adding some number of tons of metal to it actually is a bigger perturbation than adding that same amount of metal would be lower down. And so what does that do? And it depends on the chemistry. There's a path where it doesn't do much, and there's a path where if the aluminium gets oxidized in a certain way, you get this sort of reflective material in the upper atmosphere that will accelerate global warming, and also potentially the shock waves of the re-entering spacecraft create what are called NOx, oxides of nitrogen, that are a pollutant that we also don't want in the upper atmosphere and affect climate potentially. And so, I've been working with my atmospheric chemistry colleagues, and they go, well, we don't know what happens yet because we don't have the right measurements. And so on the one hand, yeah, probably the best bet is that it's a factor of 100 too small to be a problem right now.
Mm-hmm.
But the uncertainty is such that we may also be already screwed. And so it seems like it would be a good idea to kind of figure that out before we increase the amount of reentries by another factor of 10, which we're expecting to do in the next decade. And so that is an active area of science research, and the European Space Agency's just done a big study on what measurements need to be made. I'm really hoping that they're going to go and come back from that and actually fund those measurements and make them happen. But we're not there yet. And so that, to me, is a huge question that is, well, we should check this. And maybe it'll turn out that it's fine and it's not that big an effect and we can just, breathe easy. Or maybe we'll learn that we have to really change completely the way that we're doing space in order to avoid killing ourselves. And so, there are some very serious environmental questions. And really the bigger thing, right, is that in the past 10 years or so, 10, 20 years, we've gone from, we're playing around in space and isn't it cool? But we're not really doing that much. So, it won't have much impact on the Earth space environment, to now we're really industrializing space and we're having environmental impacts here, there, everywhere, right? Many different kinds, and some of them are okay and some of them are not okay. And so we really have to step back, and all the assumptions we made in, say, the 1970s about how, this is too small to matter, now that we have to go revisit that. And so I think that the space environment in general is going to become a more and more important topic, both in terms of, the classic space environment situation, right, is we've got too many satellites in orbit, they're all going to hit each other and have a chain reaction where they smash into each other. This thing that's called the Kessler syndrome, where you have a chain reaction and all of your trillions of dollars of space economy ends up as fast-flying shrapnel. That's also a concern, and that's been a concern for decades. And, there are reasons to worry that we may really be heading in that direction. And so then you wouldn't have all of the, if you trash LEO, you wouldn't have all of this sort of climate measurements and communications and everything that we depend on. And so we've really got to get serious about the space environment.
For sure. Whenever I think of space and like all these projects that are happening, I never thought environmental science and just how global warming is becoming an issue just because of satellites falling. And
might
a really big deal.
Be becoming an issue.
Might be. Yeah.
Yeah. And this is the trouble, right? Is you can't ask policymakers to make decisions on might be, although there's the precautionary principle, right, which says, well, if you don't know, maybe you should take a pause and find out first. But it's really a dramatic change, right? In the past 10 years, we've gone from 1,000 active satellites to 15,000 active satellites.
Wow.
And we might go to 100,000 in the next 10 years or more.
Oh my gosh.
And so there's just a dramatic, we've gone from evolving on the government timescale to evolving on the commercial timescale, which is much faster. And much faster than the timescale that regulations get passed, right? And so it's just not a tenable situation, I feel. And a lot of us are now on the science side getting together to kind of draw attention to this and sort of, put a little more attention on how we can do this. Because, we want the space revolution to succeed, right? But not at the cost of the rest of us.
Yeah. Like going on from that, in 10 to 20 years, what would you like the biggest breakthrough to be in this field?
Well, I think the most urgent one is really understanding how our satellites affect the near-Earth environment, and particularly the upper atmosphere.
Yeah.
And both in terms of launch emissions, in terms of re-entry emissions, in terms of the overall greenhouse gas costs of building the satellite system. And so I think we're poised to make a big increase in understanding in that. In the longer term, right, the biggest thing I want to see is a serious attempt to plan for what I call deep space. And so until recently, even today, most space activity is in a fairly tight set of orbits around the Earth. And there are two regions where most spaceships are. They're LEO, low Earth orbit, which is from, 200 to 2,000 kilometers above the Earth. That's where the International Space Station and the astronauts are, and the Starlink satellites and all of those. And then there's a place called GEO. And GEO is geostationary Earth orbit. It's 35,786 kilometers above the equator. Why there and not 35,787? The higher you are above the Earth, the longer it takes you to go around the Earth. In LEO, you go around the Earth in an hour and a half.
Wow.
17,000 miles an hour, right? Right around the Earth in an hour and a half. If you go out to the distance of the moon, at 400,000 kilometers, well, obviously it takes a month to go around the Earth, because that's how long the moon orbits, right? That's what a month is. In between, therefore, there's a height at which it takes exactly a day to go around the Earth. And so if you orbit around the equator and it takes you a day to go round,
Mm-hmm.
the Earth is spinning underneath you, it also takes a day to spin. You stay above exactly the same point on the Earth.
Mm-hmm.
And so if your television satellite is sitting in this special orbit,
Yeah.
you put your dish on your balcony and you just point it at that satellite, and as the Earth turns, the satellite turns with it,
Mm-hmm.
and it follows it, and you don't have to have an expensive moving dish, right? And
Yeah.
so there are thousands now of television satellites and other communication satellites sitting in this little ring around the Earth that's only like a mile or so thick.
Mm-hmm.
Because if you're too close in or too close out, you start drifting relative to the Earth.
Right.
And so that's precious real estate that we don't want to screw up. So those are the two places where we do space. But there's a lot of Earth orbit beyond that, and it's more complicated because once you get out to about 150,000 kilometers, so like a third of the way to the moon or so, the gravity of the moon starts messing with your orbit, and things get more complicated mathematically. And there isn't much stuff out there at the moment, and so there's kind of like a cultural difference between the near-Earth space of LEO and GEO and the deep space out near the moon and beyond and probes to Mars and Saturn and wherever. And we're seeing now a huge increase in interest in operating in that deep space regime.
Mm-hmm.
Not just the Artemis missions to the moon that people may have heard about, but a lot of robot probes doing stuff around the moon, probes to Mars. And it's a lot more international than it used to be. The deep space stuff was US and the Soviet Union. Now we have a United Arab Emirates Mars orbiter, an Indian Mars orbiter. We have European probes to comets, and so we have an Israeli moon lander. And so there's all kinds of different players, and they're commercial deep space players.
Yeah.
SpaceX, of course, but others as well, Astrobotic, Intuitive Machines, that are getting contracts from NASA to just go and return the data, but operate the mission commercially. And so we can't just play like we used to. We have to do more international coordination in deep space. And so one of my main focuses in the years going forward is going to be trying to persuade the regulatory agencies to get their act together on deep space before they get swamped by all of these asteroid miners going off and pirating each other's rocks or something like that.
Yeah. And just to wrap up, I know many students like myself were inspired by careers in science, space, medicine, exploration. What advice would you give to students like us who hope to make an impact in this field?
Right. Well, I would say, there's so much important work to be done, right? And it can be very difficult to go, which area do I move into? It can be tempting to go, well, the worst thing, humanity's worst problem right now is climate change, so I should work on climate change, for example, right?
Yeah.
But I think what you have to do is test yourself on what do you like working on? Because you will be, I decided not to do the climate science thing, although I'm ending up kind of in that area in a bit, but, what I felt is I could be an average climate scientist, but I'm a better space scientist because it speaks to me more, right? And so you've got to do what speaks to you, what grabs your enthusiasm, and then just, find something that you can dedicate yourself to. And it turns out that you can, I think a lot of students, particularly at the undergrad level who are about to go into grad school, are
Yeah.
worried that, they're making this commitment that that's what they're going to be for the rest of their lives and that they won't be able to, you have to write papers on this particular species of fish or whatever for the rest of your career, And you sometimes get told that like, you can't kind of switch because it's too much overhead. Nonsense. I've kind of, within my field, I've kind of gone all over the place. You publish less papers if you jump subfields because there is a ramp up time for changing, but the gain in keeping your interest up is worth it. And so I would say, don't worry. What you don't want to do is mess around with something for 2 years, give it up, try something else for 2 years, give it up, and never complete anything. Right? I've had friends who did that and, they end up at 40 with nothing on their resume. Right? And so it's like, now, show that you can get a project through to completion, and that's what a PhD does, but in industry you can do the same thing, but have something that you've completed. even if halfway through you realize it's not the thing you want to spend the rest of your life doing. And then once you have that, you go, look, see, I know how to deliver. That gives you much more freedom to then switch and do something else.
Perfect. I'll go by that for sure. So, yeah, now once again, thank you so much, Dr. McDowell, for joining me today. It was truly a pleasure learning about your work and everything you had to say about what we can improve in the future and what problems you're facing in this field today. I really appreciate you taking the time out and being the first guest for the Human Survival Archive. And thank you everyone for watching. If you enjoyed today's conversation, be sure to follow along. See you in the next one.